The moment you've all been waiting for is finally here. We're in video 6 of our SQLite tutorial series, and in this video we're going to be looking at SQL constraints, and specifically the most hated yet important concept of how data can be related using primary keys and foreign keys together. So let's get started. What exactly are constraints? Well, they're basically what they kind of sound like. They provide a way for the database. They basically improve database integrity by forcing certain criteria to be met for a column in order for it to be added to, in order for rows to be added or updated. It's an integrity checker to make sure that, let's say I give an intern a database and I only want good data or real data that matches, I guess, what our models or whatever the use case is, that matches what is to be expected. Essentially, it's making sure that it's good data. And these constraints, what's important about them is that they must be declared at time of table creation. And this makes sense because why would you have a table? You could have a bunch of junk data get added to it, and then you go and say, okay, I want to set constraints. Well, now you have all these rows that don't meet those constraints. It doesn't make any sense. So these constraints must be declared at time of table creation or time of column addition, such as let's say you already had a table. Okay, that's fine, but you want to add another column. We can add the constraint for this column during this column's creation. So it's really must be declared at time of column creation and table kind of. So what are these constraints? The main ones are not null, default, check, unique, primary key, and foreign key. Yes, primary key and foreign key are types of constraints, and in some ways they kind of use these other four constraints when making them. What's cool about constraints? What's so unique? We already discussed that they can force data integrity by forcing the data to meet certain criteria. And this is unlike the case for flat file databases, with an Excel sheet. Excel sheet, you can just go in and you can add whatever data you want. It doesn't have to meet certain criteria. So that's what these constraints are going to allow us to do. And the way we're going to go about discussing this is we're first going to cover not null, default, check, and unique. And then after we know these, the primary and foreign keys will come in and make much more sense. And you'll also sort of see how primary and foreign keys really in some ways are in the back end using these other constraints. So let's get into it. Not null and default. What do you think not null constraint's going to do? Well, pretty obvious. It's not going to allow data to be added if the data for that column is null. So essentially you can't add to the database if you're missing a certain column, such as this might be create a password. For when someone's creating a password, if they leave it null, okay, you don't want to add that user to the database. And in order to set our constraints, the syntax is very simple. We already saw earlier in other videos, create table, the name of the table is gradebook, and then we're putting in our columns. The column name is going to be name. It's going to be of type text. And then after that, we just say what the constraint is. It's really what we've seen before. It's just adding the constraint to it. So we say that this name column cannot be null. Simple enough. Now, default. Exactly what it sounds like again. It allows us to set, or the database to automatically set values if they are not included at time of data creation. So you see here the syntax is basically the same. Credit hours is the column name. It's an integer, and then we say default. And following the default keyword, we say what the default is. So that's going to be 12. So if anyone goes to add to the database and they add everything else, but they don't fill in this column, it's automatically going to set it to 12. So you can think if there's something happening if there's a piece of data that is constantly being added over and over and over again that's the same, then it's going to be really repetitive to fill that out. So you don't want that. and you can just set a default value so you don't have to even worry about setting it. A good like use case would be, let's say that you're doing like a clinical study and it's just like primary care patients that have cancer versus don't have cancer. Well, most of them are not going to have cancer, so you could set the default to 0. And then that way, whoever's adding to the database will only need to fill in that column if the answer is 1 or if the answer is not the default value. Such as here, if we're filling out the grade book, if we don't include the credit hours when we're adding our rows, it's just automatically going to set it to the standard 12 hours. Now, check. This is another constraint that it kind of provides much more customization to like our constraints for the database. So it can be much more specific to whatever project that you're working on. So like here we have a GPA column, which is of type real. So remember, this is kind of like your floats or decimal point values. And then we say our constraint again, check, followed by what it wants to check. Right here, we say GPA is between, that's another keyword to learn, between 0 and 4. And so this makes sense. We don't want anyone's GPA to be higher than 4 or lower than 0 because that's literally not possible. Again, an example of how constraints force data integrity. They force good data. And I included a comment here. I don't think I mentioned how to add comments in SQLite or SQL files, but just simply 2 dashes followed by the comment. Or if you wanted a, let's say a longer column, let me switch that to white. There we go. If you wanted a longer note, it would just be %, and you say what your note is, and you end it with that. So that's just a note on like what columns are. But these this check constraint, it is using this between, it is inclusive. So it will allow a value of 0 and a value of 4, which makes sense because if you're a baller student, you might have a 4.0 and it'll allow that. Unique does exactly what it seems like it would do. It forces the data in that column to be unique. It can only appear once. You can see same kind of syntax, email, text is the data type, and it must be unique. That's the constraint. So you can't, let's say it's like passport numbers or that, it has to be unique. And same with emails. You don't want users signing up for multiple accounts with the same email. It forces it to be unique. All right, before we dive into like primary key, foreign key, I first want to revisit table schema and like pragma for getting table schema. And this is really, I mean, if you're given a database that has a lot of constraints, you're going to want to look at the table schema and what these columns are because you want to know what is allowed to be entered and you want to know what is not allowed to be entered. So you don't waste time adding a bunch of data that's not good or filling in default values that are already there for you. So if we remember from the last video, it's just .schema followed by the table name, which is gradebook, and it returns to us the SQL query that was, or command that was used in order to create that table. And within that query, you see all the constraints. You see not null, default, check, and unique. And pragma, again, we talked about this in the last video, is another way to look at table schema. And it essentially returns to us a table with info like about the schema. So again, you have this automatic index column, you have the name of the column, you have the type for that column, the data type, you have whether it includes or it allows null values or not. So like here in our name column, remember we said that it cannot be null. So because it cannot be null, this shows up as 1, whereas the others we didn't say that it had to be not null or not, so it's just 0. We see now here our default value, so if there's a default value set, as we did for credit hours, it's going to say what the default value is, 12. And then at the end it shows if that column is a primary key or not. All right, before these primary and foreign keys, I want to make sure to hammer in these first 4, and we can do that by trying to do what we're not supposed to do. That's usually the best way to learn, in my opinion, especially with database stuff, is you learn by breaking it. So let's try out this not null. Let's try filling in a row for our table where the value for name, the not null column, is null, which is what we're doing here. We're filling out everything except for the name column. We see, oh, constraint. So it's not going to add the row at all because it did not fit the constraint. And that's important because you may think, oh, well, it might fill out some of the data, just not this. But no, it's not going to add the row at all. Such as you don't want a user account to partially be added. You want it to only be added if they included their email and password. So that makes sense. And we see that that is blocked. Default, we're going to fill in the name column now. And we're not going to fill in the default column, which remember was credit hours. And that's perfectly fine because SQL sees that that column was not filled in. So what it's going to do is just use the default value for that column, which is 12. Check. Let's see how this works. We're going to try and add to the database. This is, we're actually doing an update. So we're going to edit this existing like John row. And we're going to set his GPA to 5.0. What's going to happen? Not going to allow it because the GPA it's being checked that it's between 0 and 4. And look here, it's you can see that it's not going to delete our column or edit anything else. It's just simply not going to allow this update command to occur. And kind of similar to what we just talked about, if we wanted to insert a row where it's a new row and the GPA is 5.0 again, it's not going to allow this row to be added at all. It's not going to fill in the other like Matthew values. It's just not going to allow the row at all. So kind of it's a pattern we're seeing with constraints, how it's in that specific SQL command or query, the entire command's not going to happen if it does not miss or if it does not meet the constraint. You can think the transaction's not going to go through at all if it does not meet the constraints, but what's already there is going to stay there. What about null values for check? What do you think? Do you think if we did not fill out the GPA column, would it allow it? Well, we already kind of saw that. Check will be okay with null values. It is just making sure that a bad value is not added. Null is completely fine. So we see here it adds just fine. Unique. What's going to happen if we add a duplicate email? Remember, our email column is the unique column. So we're going to do two different rows for two different people, but they're both going to be using the john@gmail.com email for when we update the data. We're updating first we want to fill in John's email. That's what we're doing here. That's going to go through just fine. But then when we go to update our Matthew row, it's not going to work because this is duplicate. And you see nothing, since it was an update, it's not going to delete the row, but it's just not going to successfully add our repeat email. For new rows, what do you think is going to happen? Exactly what you would expect. It's just not going to add the row at all. It's not going to add any of the data there. And that's because John's already being used. John@gmail.com is already being used. Now, is it case sensitive? This is something important to kind of think of. What if they're still using john@gmail.com, but this time they use a capital J? Well, it's going to work because unique is not case sensitive. And there's some things that you can kind of do to change it to be like case sensitive and some other tricks that you can do, but we're not going to cover that here. Just know that by default, unique is not case sensitive, and you have to be watching out for that because with emails, we know that emailing someone, no matter what capitalization we use for their email, it's going to send it to the same person. It's really the same email. So that's just something to keep important note of. All right, primary and foreign keys. Before diving right into primary keys, I want to kind of do a compare and contrast between primary key and unique constraint because they're similar but different. We know that unique does allow null values in the column, but the case for primary keys is that it does not allow null values. Primary keys are unique identifiers or IDs for a row in a table. So essentially that piece of data in that primary key column is going to be a way that other tables can know how to like reference a specific row. It's a unique identifier for that row. So if it's a unique identifier, similar to unique, this is where they're similar, is that it must be unique. So really it kind of has an inherent unique check and a inherent not null check inside of it, because you need a way to reference the rows. So it's not going to allow duplicate rows, because you don't want to reference or have the same ID. Let's say the ID is both 1. If you want to have another table reference that row, it's not going to know what to do because it's seeing 2 rows that have the same primary key. It's not going to be able to differentiate between them. So again, primary keys cannot be null and they must be unique. Now let's actually go ahead and create a table that is going to use primary keys. We're creating a table called students. We have a column called ID, which is going to take an integer, and then we say our constraint. So the syntax, really, it's the exact same kind of syntax. We say the name of the column, the data type, followed by the constraint. The constraint is primary key. Then I also just added a name column that's text and doesn't have constraints. To this table, let's add some values or some rows and see what happens. We first add this row where their ID is 1 and name is John. Okay, great, that's going to work just fine. Now let's add another row where the ID is also 1 and the name is Matthew. This isn't going to work because remember that primary keys must be unique, so this entire row is not going to be added. Now, how can we kind of automate the creation of primary keys to make sure that we're not using duplicate primary keys? Because it may be annoying once you have a crap ton of IDs. It may be easy to enter an ID that's already been used before, and we want to take that power out of whoever's entering the data. We want to take that power out of their hands. And what we can do to automate like primary key creation and the values for them is use what's called auto increment. So you see here, we first drop the students table because we're adjusting like the columns and constraints. We create the students table again this time, and this part's the same, ID, integer, primary key, and then we just add on to auto increment it. What's going to happen is that anytime we go and add a row, it's going to automatically generate the primary key for us, and it's usually in ascending order. So we see we insert this John row and we insert a Matthew row, and we see that it's automatically made for us. So because this was the first one run, it gives it an ID of 1, and then it gives it an ID of 2 for the next row. So that's pretty cool. We don't even have to worry about filling in the primary key if we use auto increment. Now let's discuss foreign keys. And again, remember what the primary keys are is a unique identifier for a row in a table. And these foreign keys, the foreign key column, is going to exist in a separate table. So what we're going to do here is, first I just want to drop that gradebook column, and we're going to make it again, just this time having foreign keys and getting the name column out of it. But how would we do that? We just exactly the same way as we would normally do. So you see up through here, nothing looks unique. But then we add at the bottom, and this is where it's a little bit different than our other constraints, where it's kind of in the same line as the column. We just say foreign key followed by what column is going to be the foreign key. And then we say that it references, and then we say the table name that it's going to reference. It's going to reference the ID column in the students table, which remember this ID column is a primary key column. And we see that even better here, how we have student ID. So the foreign key is the student ID column, and that's within the table itself. Like the foreign, where we're saying that's a foreign key is within the table itself that contains the foreign key. Okay, the student ID column is the foreign key. And what the student ID is gonna do is this column, we are basically giving the table additional information. We're saying that this student ID column references or matches up with a primary key in another table called students. where the column is ID. The column that contains the primary key is ID. So you see that basically at the end we have this student ID column is in some ways pointing at or saying that it's related to the ID column in the students table, which that's just right here. This is the students table. All right, now that we've discussed primary and foreign keys, we can actually go about using them and doing our play it learning by breaking it. But in order to do that, we must first importantly note that by default, this foreign key constraint is not going to be enforced unless we set the variable. It's kind of like an environmental variable for the database that you're working in. Unless we set the foreign keys equal to on. And you see we do this by using our pragma command and the foreign keys variable. We set it equal to on. It would have by default been off. We're just setting it equal to on. And so that's going to force the constraints that foreign keys bring. And we're just about to see that basically how once we turn it on, it's going to make sure that only valid foreign keys are added. Essentially, only valid foreign keys that reference a valid primary key in another table. So let's see how we might break it. We're going to insert into gradebook. That's our new column. We're going to insert a student ID, GPA, and email value. And what we see most importantly here is that we're setting the student ID equal to 999. That's not a valid primary key in our students table. What's going to happen? It's not going to add the row at all because it is not referencing a valid primary key. 999 does not exist in the students table. We only have 1 and 2, so that's not going to work. Now, what are we going to do here? We're going to insert into gradebook again, the columns, but this time we're going to add a valid primary key, which is 2. So this exists in the students table, so it's a valid primary key being referenced by the foreign key column. And we see there, it's valid, and it works. Okay, now, great. We've added this foreign key or this row containing a foreign key successfully and correctly. How might we actually go about using the power of primary and foreign keys? Basically, how can we actually use the relationship that was created at time of data entry? Well, we're going to talk about join and delete again, which we did in the prior videos, but this time it's going to make much more sense. We're going to select students, so that's the name of the table, students.name, that's the name column. And we're also going to select from the gradebook table, the credit hours column, as well as the GPA column from the gradebook table. And remember, with select, this is just what's going to be shown at the end of the day. It's not really the magic going on here. It's just what we want to see after doing our join. And we're saying from gradebook, join students. So we're going to join remember it's kind of horizontal. We talked about union, which was kind of like stacking rows. Remember that join is rows, squishing them together horizontally. We're going to join the gradebook table with the students table. And what are we going to join them by? It's basically asking what rows, how can we tell what rows should be like together? We're going to say that it's where the gradebook student ID column. So remember, this is what is this? Yeah, this is the foreign key right here. We're going to say that this foreign key or student ID column is going to be where it's equal to the ID column in the students table. So basically we're saying to match up where the primary key equals the foreign key. That's exactly what this statement is saying, is join them based on the primary and foreign key matching. And we see here, bang, it matches them together. So it's only going to show one because there's only really one match for where the gradebook.studentID column equals the ID column in the students table. And we see here, we're given a combination of the two tables together based on that primary and foreign key relationship. And then what I kind of just show here is how like really flexible the syntax is for this join and primary key. So basically I just kind of messed around with the order of changing it from gradebook and then saying students, and then doing the opposite, saying that it's from the students table and then gradebook. We see that that's, I mean, no matter what, which way we do it, it's still going to work the same way. And just kind of shows here too how it doesn't really matter if the ID or student ID is mentioned first. And that's just something to note, is that it's the syntax is pretty flexible for your join and primary key statements. You just have to make sure that you're matching them on the right columns with the primary and foreign keys. Again, I just said here, again, make sure that pragma foreign keys is on. But now we're going to talk about delete. I guess that's why I reference it, is because we're going to be able to delete kind of any rows that we want if we do not set that pragma foreign keys value equal to on. It's not going to restrict deletion. So that's something that's pretty important to note. What happens if we try to delete the primary key, a primary key that is being referenced by another table? So we see here, we're trying to delete from the students table the row where the ID or primary key is 2. And this is not going to work because in our gradebook table, this primary key row is currently being referenced. So if it was deleted, then the foreign key table, the table with the foreign key, is not going to be referencing a valid primary key anymore because it doesn't exist. So it's really important to have that pragma foreign keys on to keep your data integrity so that we're not deleting primary key rows that are currently being referenced. You want to first take care of those foreign keys before actually deleting a row like that. Now here, what do I say? Delete from students where the ID equals 1. So what we're doing is we're trying to delete the row in the students table where the primary key is 1. And this is going to work because remember, we only set the foreign key for we only set the foreign key in our gradebook table where the ID was 2, or like for Matthew. So because this table with the foreign keys does not reference the students table where the primary key is 1, we can successfully delete that row from the students table. To kind of just summarize, this is going to work because no foreign keys are referencing the ID of 1 or the primary key of 1. So that works just fine. And then we can kind of see how auto increment works. After deleting that row where the ID is 1, let's say, okay, we want to add John back to the students. That's going to work just fine, but the ID is going to be 3 now. And this is just sort of how auto increment works, it kind of keeps in the back end what number in like the count or the increment we're on. So it knew that we added 1 and 2, so it's expecting to add 3 next. And that's exactly what it's going to do. It's not going to add 1 again because it kind of thinks that 1 already exists in some ways to it. So it sets its ID equal to 3. Now, what if we wanted to actually insert that 1 back? Well, it's going to work. That's pretty cool because look, what we're doing here is we insert into the students table values where we're setting the primary key manually. Remember, auto increment was kind of doing it automatically, and that's why it gave us the value of 3 for the ID. Here we're adding it back manually, saying that the primary key is 1, and it's going to work because that 1 does not exist as a primary key anymore. And from there, we're just going to delete that row where the ID was 3 again. And this kind of just shows how really powerful primary keys are for deleting, because we can reference a single specific row that is to be deleted, and we won't accidentally delete several rows where there's a matching ID of 3 because you can't have matching primary keys. So it just goes to show how selective and important primary keys are. All right, let's summarize it because that was a lot of yammering. I even almost got off track there. primary keys are for columns that uniquely identify the specific row. So they are, you have a bunch of rows and you have a column that's a primary key column, and the value inside of that primary key column is going to reference a specific row. So we know that it must be unique if we want to access or identify a specific row. We know that the primary key has to be unique. We know that it cannot be null because we need a way to reference the rows. And we know that auto increment can automate the creation of our primary keys for us. And we also know that we cannot delete rows if they contain a primary key that is being referenced by another table through the foreign key. And foreign keys again, foreign key is essentially going to tell SQL that a column in that table is referencing external primary keys. We know we have to turn the pragma foreign keys variable on in order to force the constraints. And we know that we cannot add to it unless it references a valid primary key. And we also know that rows containing foreign keys, they can be deleted. But this is important. They can be deleted if that row does not have its own primary key that is currently being referenced by a foreign key in another table. Like, let's say we created a third table that had a foreign key column and it's referencing a row in our gradebook table. We can't delete the foreign key row if the primary key for that row is being referenced. So we can only delete it if it doesn't have its own primary key being referenced. And this video is getting kind of long. I'm already getting lost a little bit. So I think I'll end it here. But in the next video, we're going to really hammer primary and foreign keys even more and see how we can really use constraints and to create database relationships, and how the ways in which we use primary, foreign key, and unique constraints can allow us to force and develop relationships between different tables, such as one-to-one, one-to-many, and many-to-many. So I hope you all didn't get too confused, and I think this next video should really help out in terms of primary and foreign keys and how important and crucial they are and just how coolly they can be used. So I hope you all stick around and take care.